Uh, Hi friends, it's me, CM Cabby. Hello, how is the sound sounding? Is the background music too loud? Am I too quiet? Please let me know. But if there's no problems with the sound, I am here today to welcome back our very own MapleStory World software engineer, John, aka Ursus. If for those of you in the MapleStory World's Discord server, John is here today to go over, what is he going over? Character and player states and animations in the MapleStory World's Maker in this creator-focused live stream. But before I hand it over to John, I just want to remind everyone of our upcoming game hours. This week we've got game hours where myself, CM Suki, and a few other Nexies hop into a specific world to play games with you all. And for this week, we are going to be hopping into Maple Soccer, which we featured on the live stream a few weeks ago as one of our winners of the 90-Day Creator Challenge. For those of you who don't know what Maple Soccer is a fast-paced arcade-style soccer game that has 1v1 and 2v2 PvP modes. You can find, let me copy and paste, the Maple Soccer link here. I think that's it. Okay, that's sent. And today we'll be in Maple Soccer from 4:30 p.m. to 5:30 p.m. PDT, which is Los Angeles time. And what else? Okay, so before we move on to the main part of our live stream, before I hand it over to John, I'm going to drop another link to our July 15th creator live stream survey. And what do we want you to do with the survey? For creators who watch today's live stream on character and player states and animations, we'd love to know your thoughts. Like if you'll use what you'll learn today in your current or future projects, if your understanding of today's topic is improved, etc. And I am going to hand it over to John right now.
Awesome. Thank you so much, CM Cabby. So as she mentioned, today we're going to be going over states and animations. So essentially what this means is when you're scripting in MapleStory World and you want to take control of animations, each animation or each monster or player is going to be always in a certain state. The state doesn't necessarily imply the specific animation or the timing of the animation. It's more to do with the group, or I guess the execution group as a whole. So if I'm currently, I am live, June. I'm sorry, previously I haven't been paying too much attention to the chat, but today I am focused in. So if you guys have any questions or if you guys have anything, please let me know. So as I mentioned, a state is more so not specific to the animation, but currently the state that the animation or the character is in. So it could be if you're inside of the attack state, then you trigger some sort of attack and you play the animation. So when you're working through MapleStory scripting and you want to script an enemy behavior, which is what we're going to be doing today as an example, we're going to kind of try to script or I guess go through what a state system might look like with a monster. So let's get into today's example. So today we have this friend here. It's a very simple kind of enemy. And when I press play, we can see that if I'm far away, he just kind of does his own thing. He wanders around from place to place. And then if I move closer, he starts chasing me. And as soon as I move back away, he starts doing his own thing again. And then if he gets close enough, then he'll start attacking. And notice that there's a specific timing with the attacks where I don't get damaged, by simply interacting or being close to the enemy. There's a specific animation timing when I actually take damage from the enemy. So this is kind of what we're going to be looking at today. So what you may kind of notice behind the scenes is currently there are multiple animation states. There's attack 1, attack 2, there's a move state, there's a stand state, there's a death state, there's a hit state. So if I interrupt and I hit the enemy, you'll notice that he kind of interrupts his attack. So let's take a look at, or I guess let's go over a brief overview of the systems kind of surrounding this. June, unfortunately, I won't be able to answer questions that are not relevant to today's stream topic. So if you have questions about today's stream or something specific to states and animations or a question on that, I'd be happy to answer that. But yeah, today I'll be focusing strictly on states and animations. Okay, so we have our monster here and we have several different animations. So we have a lot of different states here. We have a stand state, we have a move, we have attack, attack 2, hit, and die. So we have each of these states has an animation associated with it. And if we kind of picture this as a kind of a graph. So if you take a look here, so we have our move state, we have our stand state, and then we have our, ignore this kind of yellow box on the side for now. We have a hit state, we have a die, attack, attack 2, and stand. So each of these states, we're going to make sure that we have proper conditions, that as we move back and forth between these states, we're going to, certain conditions will trigger the transition between these two conditions. And while it's in a certain state, it will be able to execute the behavior of that specific state. So this is kind of the flow that we're going to try to target to create. Yes, so June, if you have a question on animation, then yeah, please ask. Or if you have a question on states and animations, if something isn't clear in today's stream, please let me know. Okay, so let's take a look into our documentation on states and animations just to get a brief understanding of our of the API and systems as a whole. So we have an overarching states class. So we have our state type. Each state type has, we have a state component, and then we have state types. So state component is going to be, I guess, the manager of the states. So it's going to contain all of the states that we saw earlier, the move, stand, hit, die, attack, and attack 2 states. It's going to contain and is going to manage the states, and is going to be in charge of moving back and forth between those states. So we have, when we add a state to the state component, that state component has a few built-in events. So we have an onEnter event when a state enters into this event. So when a state enters into the move event, this function is executed. While it's running, it will call the onUpdate. After a state is completed and it exits, it will call the onExit. And then when while the state is running, we can define conditions for it to move to and transition into the next state. So as an example, we have this function here, test animation states. We're going to go into a more advanced implementation of states and animations in just a moment, but just to get a basic conceptual understanding. So on our entity, our monster entity, we have our custom state controller. Now this is an extension of the base state controller. Um, sorry, it's called the state component. So this is an extension of our base state component, and we can see those add states, add condition functions here. And we have extended this script so that we can create our own custom implementation of states and animations. But we're going to ignore our custom implementation for now and just work with this base state. So if we remember, we have, let me bring up my diagram one more time. We have all of our states. We have a move, stand, hit, die. To add a state to our state component, first we have to add and we have to define the behavioral logic associated with each state. So we can say state component, state, and then we have two inputs. So we have our state name, and then we have our state type. This first, with the update function, this is deprecated, so please do not use this one. Use the one that has the state type, which is going to be the more proper way to implement states. But when we add the state, so first we have to add the move state, so we're going to add move. And then we have our state type, which we can create. We can create a new state type. I'm going to create a quick folder in here. And then we can create a state type and then say my move state. We're going to save that so that we can apply it to our local workspace. And then we can say my move state. So with that, we have defined the state, and then we also have defined the behavior that is associated with this state. So if we open up our states, we open up this script, we have our my move state. So on the my move state, we have on enter, we have on update, we have on exit, and we have on condition check. So the condition check is going to be what will actually define when we transition into the next state. So we'll go into a little bit more detail of the of how to script this portion, but let's go back and start fleshing out some of the other states that we have. So we have stand, so you have state component. So we have the stand state. And then I'm going to just pretend that we've created these states so that we don't have to keep going back to the maker and creating this. So we're going to say my stand state and pretend that exists. And then we can do state component, add state, and then let's say attack. And then we can say my attack state. So now we've created these states, and we can now define the conditionals that goes between these states. Yes, so Zuitat, sorry if I'm pronouncing your username incorrectly. So that's a great call out. So MapleStory Worlds has default states that you will have to, if you want to override and add your own custom implementation of these, you have to make sure that you are removing those states and overriding those. Or If you're not going to use the more custom implementation that I will show you after we go over the basic overview, then you can keep them, and then you can manually add transitions between the idle and dead state. So if you go into our documentation, this is the controlling entity status documentation. And in here, we can see that we have, by default, we have idle and dead states. By default, these are just added in automatically with the state component. So reminder, this monster state controller, our custom state controller is an extension of our state component. So the idle and dead states are also going to be added here. So when we move into the state transition and event occurrence, we can also see that there are other states that are added depending on what kind of component that you're adding in. So for example, if we add in the hit component, it also adds the hit state. I believe that the AI move component is going to add the move state. The AI wander component is going to add the move state. The player controller adds all of these states. So if you want to add a custom implementation, you can remove those states like I do here. State component, remove state, idle, dead, and hit. And then you can create your own implementations like I have. My replacement for idle is a stand, and so on. Okay, so when we transition between our various states, so we have our attack. So let's capitalize this. And I'll go into why in just a moment. But we have our various states. We have move and attack. To transition between these two states, and again, keep in mind that we have our controller set up here. We can do state component and condition. And then we have the first state that we're going to add. We have move, and then we can transition into the attack state. So how does MapleStory know to transition between the move to the attack state? Well, that's where this condition check comes in. So this is where we can define the conditionals for transitioning between my current state into the next state. So if my current state is move, then I can add in logic in here to say if I'm not going to write out the full logic, but just with pseudocode, let's say if player is in range, then return true, else return false. So if it's false, then it will stay in the current state. If it's true, then it will transition into the next state, which is going to be the attack state. So we can also, if we, let's say we had multiple of these, we had another state, let's say a hit state, and then we can say my hit state, and then we can say state component dot add condition. And we can say hit. Sorry, we can say move, and then hit. So now that we have two different transition logic, and we only have one controller, what we'll have to do is we'll have to do an if state switch. So we'll kind of have to do a switch logic where if we say if next state name equals attack, then else if next state name equals hit. And then we can move this logic into the attack. and then we can have our other handle hit logic here. And in this way, we can have our different conditions from one state to have multiple different transition waypoints. So from the move state, we can transition into the attack state. From the move state, we can transition to the hit state, depending on the conditions here. So why does the capitalization of these states matter, and how does it know to actually move into the state? Well, if we go into the self dot parent component dot current state name, so the parent component is going to be the state controller, and then we can get the current state name. So the current state name will be if whatever state my animation is currently in, it will be in my monster controller, these here: stand, move, attack, attack to hit, and die. So from move to attack, it is basically just the lowercase version of the state that I defined here. So by automatically, when it transitions into the state, our state controller will attempt to play the animation defined by this state animation component here. So we don't have to manually play the animation as long as the names match the state animation component here, and then it will automatically play those animations. So this is really it in terms of the basic implementation of the state animation or the state controller, and how to transition between various states, how to define various states. And again, like I mentioned, you do have to keep in mind that by default, we have the idle and dead state. So if you have a custom state, or if you have a different name for your state, make sure that you are either removing them or properly accounting for these states. So these states by default will not have, when they're added in, they won't have a custom, they won't have a custom state controller. So if you want to have a more custom implementation, you'll have to remove the state, re-add it with your custom state controller so that it knows how to transition between the states. Okay, so from here, let's take it a little bit further, and I'm going to I'm going to delete this. I'm going to delete these. Sorry, actually, before we move on, I realized that I didn't go over the other states. So on enter, like I mentioned, is when our animation, or when we first enter into the state. So here is when we can do our initialization logic. Let's say it depends on a certain component, or if you want to bring in logic from a different component. This is likely where you're going to be doing your initialization stuff. And we can do the parent component dot entity, and then we can grab our my component here, and then we can do initialization logic, anything we want. We can set variables and properties based on this component value, and then have on update. Let's say on update, you want to continuously move towards a certain target. We can do that here. On exit, if we want to do kind of more destructor type of values, if you want to destroy certain things, and cleanup scripts. As we exit this state, we can make sure that we use this on exit function here for that. Okay, so with that, we will exit this, and then we're going to delete this custom one, or this example state, so that we don't break anything in our code. And then let's remove this. Okay, so here is a different approach to to animation and state setup. So we don't have to necessarily go along with this approach. You can customize or implement your own approach. But the reason why I favor this approach is we are not going to be transitioning based on state controllers, where we have a separate state controller for every single transition conditional. We instead have trigger conditions based on various values. So for example, I can add my custom state. So in my custom state component, I have added a custom method where I can add a state with certain information. So I can have a state with an execution. So if it reaches 50% of an animation, then I can trigger an attack, or I can trigger some sort of method at the end of a animation. So at 100%, then I can trigger the end, or I can trigger the end of a certain state, or at the end of the die, I want to make sure to destroy my entity, so I can have the die function here. So in this way, I can have, number one, more control over the states and what happens in the behaviors within the states. And I can control more dynamically control the triggering conditions between those states. So what I have down here is I have an add trigger. So when I add a trigger, I can say that we have various Boolean and or integer or trigger. So I have a custom type auto off, attack auto off. So this is a Boolean where here we have our variables here on the side, and these are what these are. These are all the variables that we've defined. And we can say if we have a trigger type value, then when we go from move to attack, both the attack trigger as well as the attack index have to meet these conditions. So if the attack trigger flag is true and the attack index is 1, then I will transition into the attack. Otherwise, if the attack trigger condition is true and the attack index is 2, then I will move into the attack 2. Between the move and stand states, I can also define a Boolean where if it's currently if the is move Boolean flag is true, then I can transition into the stand state. If it's false, then I can transition back into the move state. And in this way, I can control based on Boolean values and more by value instead of by setting specific states. So here we have defined these values, and then Zuito, yes, these are not necessarily, it's just more of like kind of a coding practice. So this isn't necessarily a pattern but per se, but here we can see that I have my init. So I'm creating a new object. So we have our trigger auto off, which is an extension of the trigger type. So my trigger type, go to the definition here, has an initialization function where it returns the trigger type value itself. So it returns the self, and it just makes my code a little bit easier to read personally. This isn't necessarily the best way to do it or necessarily the cleanest, but it just makes it easier for me where I don't have to have a separate line for initialization logic, and I can just define the initialize or call the initialize function in the same line I define it and pass that entire thing in as a parameter. So let's call this a helper function more so than it is a pattern. But yes, so we've defined all of our trigger values, and then we have our condition with trigger, where here I can have my stand value and my very similar to the way that we've saw before. It's the same thing where we're defining conditionals, transition conditionals between the stand to attack, except now we're going to check if this a certain boolean or a certain value is going to match the proper comparison. So we have, so please let me know if I'm going too fast or if something's not clicking, so I can kind of explain in more detail. But we have our comparison type here. And this comparison type is just going to have the type value, or the value, the type, and then the value. So here, we're going to have our comparison type, which is going to be either greater than equal, less than equal, or equals. So we can say that if the attack is equal to true, then we're going to transition into this attack. And we're going to do the same thing for each of these. And this is basically a setup of this entire structure. So we have between stand to attack, we have our attack trigger, and our attack index is 1. And then attack 2, we have our attack trigger is true, and attack index is 2. And then from stand to hit, we have to make sure that our hit flag is true. If it's dead, then we have to make sure that our dead is true. This is just a setup of this kind of diagram and this flow. Okay, so after we set up all of our conditionals here, then at the bottom, we're going to simply call set the first state, which is going to be our stand. So again, by default, your initial state will be idle. And the reason I've changed it to stand is so that I can have control over the states based on the custom states that I've defined. And I can control, the transitions between my various states based on my own custom logic. So we'll go into a deep dive of, we'll take a look at each of these functions in more depth and go over the full kind of flow. But just as a conceptual overview, let me continue down into this here. So we're setting our initial state to stand, and then from stand, it will follow based on the logic rules here in this diagram to move to the various states and then to and from these states. So for example, if I have key down event, and then we have our key press F, and then we have our self.test. This test simply sets the attack index to a random between attack 1 and attack 2, and is going to set the attack to either true or false. So let me just comment some of these states out just so it doesn't override. So if I press F, we can see that I am triggering certain attacks. And it's randomizing between attacks despite me not going through the AI behavior logic that I've set up. We're going to go into AI possibly in a future webinar. I'll go into more detail of the AI systems behind this. Today, we won't have time to go fully into AI states, but we're just going to go over the behavioral states today. But again, notice that our actual attack is tied to the animation itself. So if I interrupt the animation, then the attack will not occur. And also if I manually trigger it, it will also play the attack, or I guess trigger the attack logic. Okay, so in this way, we have, instead of more on thinking of it as states, we have our states kind of automatically running based on the conditionals that we've set. And then we just simply set Boolean values of the state controller so that it can kind of just automatically kind of function based on those state conditionals. So this is not necessarily, you know, the way that is recommended. I just like to think of it this way. I personally come from Unity. So those of you that maybe are more familiar with the Unity state controller and that kind of state machine flow, this will be kind of more in your lane. So that's why I kind of went through this route. Okay. So then how is it currently setting all of these, or I guess actually going through? And as I mentioned, I'm not going to go into a deep dive of the AI stuff, but here we have our AI states and our AI behaviors, and these AI behaviors are going to call these state functions depending on the current state, and then it's going to set those values. So if it's currently in the stand state or the attack state, then inside of each of these AI nodes, it's going to call, depending on the current AI state it's in, these state functions. So if it's in the stand state or the attack state, it will set the relevant state component values so that it can transition into the proper state depending on the current state. Okay, hopefully that makes sense so far before I go into a deep dive of the actual logic itself. This part is going to be maybe possibly a little bit dense. So this webinar will be recorded, so if it's a little bit too hard, please kind of go through it again. Copy and paste the code and test it out yourself and see how it works. But okay, so let's go first into our custom state controller. So as I mentioned, this is an extension of the state component, so we have to make sure that we are removing the initial state component that comes from our preset. So when we first drop in our monster in here, we have this state component. We need to make sure to remove that, but we don't have a way to remove it, right? Because this is a model in the preset list. So we have to break the preset connection by up at the top, we have a little hamburger menu and we can click on break to break that kind of, for those of you that are maybe more Unity oriented, the prefab connection. And then now, if we go down into state component, we can remove this component. And we can remove the hit component, the monster component, whatever we'd like. We also, for my specific case, because I have my own custom AI, I've also removed the AI wander component because I've manually implemented that based on my states. So I will also remove the AI component. I will add in the base AI component. This in and of itself doesn't have any behaviors. Those behaviors are added based on the AI states here. So this is where it's all initialized, and the actual states and behaviors are initialized there. And then we will add in our custom state controller. So there it is. So in our custom state controller, we have our add state with info that we saw up here. We have add state with info, and then we're going to pass in the state information type. So we have our state info type and our state info type. has a couple of values. We have our state name, we have our state percentage, and then we have our on execute value. So we have that kind of pattern where we have with execution that we saw in here, we have our initialize function that returns self. And then we also have the with execution, so we can kind of chain executions together while still kind of creating a new object. So with certain states like the attack, we have an execution percentage of at 50% of the animation, we want to trigger this attack function. And the attack function is just going to call the monster attack near and pass in the damage. So the damage is up here where I have different damage values depending on the attack it is. So if it's the first attack or the second attack, if it's the first attack, it has 10 damage. If it's the second attack, it has 5 damage. These are kind of hard-coded values for the sake of, this webinar. Ideally, this would be kind of more in a configuration file so that you can kind of easily balance those values instead of being hard-coded into this here. But I digress. Okay, so we have our custom state controller, we have add state with info, and we've added this state. And then we are adding the trigger. So we have this add trigger, and we have a trigger table. So with the trigger type, we can see that we are initializing our trigger type with the trigger ID, which is attack, and then the value. So the value is of any type. So that when we do kind of a comparison check, and this is where the comparison will come in, where when we execute the comparison, we will match the value to the target value, which is going to be here. When we add the comparison, we're going to compare this trigger with the target comparison value with this type of comparison conditional. So we have added that condition with the proper trigger. We've added in a comparison, and then we've created a connection between this current trigger. So if we have this connection, then we know that we have a state information to retrieve. And then if it has a comparison, then we can kind of go through the list of comparison and then make sure that all of those are true before resolving the final state machine as true. And then at the bottom, we have our add condition. So this is just going to be the base function from the state component where we add the condition, and then we have our reverse result. The reverse result will basically, if the condition is normally true, reverse result will check for the opposite. So it will check for false inside of a condition in order to resolve into the next state, effectively kind of reversing the state. Okay, so that is our custom state controller. And then we have our get triggers by state, where we are grabbing our triggers inside of our state machine. And we'll go into this right now. But when we enter into our state, we have our onEnter function, and then we have our state controller that we are initializing based on the parent component entity custom state controller. So here we have our animation component, and then from here we are grabbing the animation name. So this will allow us, so I have a utility function here where it allows us to get the length of an animation. I won't go into this just so that we're not digressing too much from the original topic, but this will just give us the length of our animation depending on the frames. It'll count all of the clips from the current frame to the target frame, and then aggregate the delays to get the final animation length. So that's what we're doing. I have an arbitrary value of 1000 so that it just always does the maximum number of frames. And then here, if we have a state information, so this is going to be based on the connection. So we have, if we've added the state, then we can see that we'll have the connection here. And then if it has a connection, then it will have a state information. So if state information is not nil and the execution function is not nil, then we will wait for the state information's execution percent times the animation length, and then we're going to set a timer so that when at the time of our desired execution that we define again right here with the 50% of the animation, we're going to execute the state information's onExecute function. Then inside of the onCondition check, here we're going to loop through all of the triggers that we have initialized inside of this onEnter function. And then we're looping through each of those triggers, and then we're going to check if the trigger has a comparison. So we're going to check the trigger's comparison by the next state name. So if it has a comparison to the next state that we're trying to move into, then we're going to do a check on the trigger. So we'll take a look at the check function inside of our trigger type. So in our trigger type, sorry for the code completion, don't know why. Syntax highlighting is a little weird right now. But inside of our check function, we have our comparisons, and then we're checking for the comparison type. If it's equal, then we're going to do a straight equal. If it's greater than, then we're going to do a greater than, and so on and so forth. If it's greater than equal, less than equal, and they're going to return the result of our comparison check. So what this means is if we have multiple conditions, like for example, we have here, we have both of these that are required to be true before moving into the next condition. So that means that if we have two conditional triggers from move to attack, we have to ensure that both of those are true before we can move into the next state. Otherwise, we won't transition at all. If it doesn't have a trigger, then by default, it'll just wait for the entire animation to complete, which is why we have this timer here, where in the case that we don't have a trigger, then we will just wait for the trigger condition will just be, is my animation complete? And if it is, then it'll just move into the next state. So that will apply for states that don't have a condition per se. Let's say we didn't have this conditional here. For move to hit, it will always move into the hits after the animation duration is complete. And that's really it. That is the full kind of cycle here. We have our on exit finally. Sorry, I said we're done, and then we have one more. But on our on exit, we have, so we saw earlier that we have a special state. We have our trigger auto off. And this has an on exit condition where every time we exit our state, it will automatically set this conditional to false. So meaning that it won't stay in the state forever. It will basically, as soon as it enters, it's going to set the state to false and then move out of the state until such time that the value is set to true again. So again, this is very similar to the Unity trigger, where if it's set to true, it will enter the state once and then leave. And then we don't have to manually set that value to false again. We can just set the trigger once and then it'll just automatically set to false on exit condition. So that's really everything in terms of the kind of inner workings behind this state. Hopefully this was a little bit helpful for those of you that are new to states and animations and want to kind of implement state systems. You can take this further And something that I was thinking would be interesting, but I didn't, was a little bit out of scope for this webinar, is you can also add in things like, you know, invulnerability frames where maybe you can have multiple executions where at a certain percentage you execute a function, and then during this time frame, or I guess during this percentage range, we say that the monster is invulnerable to attacks, so it won't take damage during this attack. So I think there is, you know, a lot of cool things that can be done with states animations, a lot of kind of custom implementations and management of these states. And hopefully you guys can take it further than I've done here and implement this into your own or variation of this, or you can use the base kind of state system and kind of implement that logic as well. Zuitat, would you recommend to create monster models, setting the action sheet and spawning monsters using spawn service? Or can I set the action sheet through coding? Yes, so you can set the action sheet through coding. If I remember correctly, the state animation component, the state controller has it has a state, let's see, self dot oh gosh, I forget where we can set the animation sheet, but yes, you can you can set the animation sheet through code, and you can manually, and this is why kind of this system might be more helpful for more dynamic. If let's say the trigger conditions change, you know, a monster moves from the first execution to the attack, or a different execution, the monster suddenly loses an arm and it can't attack anymore, and then now it can't transition into this state. Yeah, so you can set the action sheet and kind of update this manually. And that's it for me. Hopefully this was helpful. And I encourage you to check our Discord community and ask any further questions to our community. And good luck with your projects. Hopefully everyone does well. And thank you so much. I'll transition the mic back to CM Cabby.
Hello. Thank you, John. Making sure that you can hear me. Okay. I am going to drop the link to our creator livestream survey for today one more time. Please fill it out. Let us know what you thought of today's creator livestream survey, or creator livestream. And then the link will also be posted in Discord shortly after the live stream. Now some housekeeping. Our next live stream will be Tuesday, July 22nd at 11 a.m. PDT, aka Los Angeles time, so 1 week from now. For that live stream, we'll be going into Durango, the Lost Island, a little more closely in part 1 of our Durango the Lost Island series. But what is Durango the Lost Island? It is a survival game and an Nexon original world where I'll be fighting some dinosaurs, do a little base building, hopefully not die, but we'll see. And I think that's it for me and the MapleStory World's live stream. Again, thank you, John. If you have any questions, please head over to our MapleStory World's Discord server, and we'll try to get them answered for you. Thank you for joining me and John. Okay, bye, friends.